Okay, 7th graders, we are on Lesson 2, Session 2 in your book, which starts on page 37. And yesterday we did a fraction in a fraction. Today the only difference is we're doing two fractions in a fraction. So it's a fraction of fractions of fractions of fractions. And so our try it activity that you will hopefully try on your own, but regardless, I am going to also do it over here. So Julio and Kyle hike along the same trail. Kyle hikes the first 6 miles in 2 hours. And over here we've got Julio hikes the first half mile in a quarter hour. And the question that we are being asked is, who hikes more quickly? Who's faster? And in order to be able to compare them, they need to be the same rate. So we want to find the unit rate here. The unit rate, and that's going to be per hour because our time is hours. We don't want to know how many hours per mile. We want to know miles per hour. That just makes more sense, right? So we're just going to create a unit rate for each of these and then compare them. So Julio is going a half mile in a quarter hour. So there you go. There's your complex fraction. It's a fraction in a fraction, but all of that is a division problem. So it's half a mile divided by a quarter hour. But I need to remind you that since it's the hour that we want the unit rate for, the per hour, that goes on the bottom. That's an important part to remember. And then for Kyle, he's going 6 miles in 2 hours. That one's much easier, right? That's just 6 divided by 2. You could rewrite that if you want, 6 divided by 2, but you don't need to. You know 6 divided by 2 is 3. He's going 3 miles per hour. Now for Julio up here, we're going to figure this out by doing keep, change, flip. So keep, change, flip, and then for multiplying fractions we just multiply across top and bottom. 1 times 4 is 4, 2 times 1 is 2, and then this is another simple division. 4 divided by 2. 4, you don't even have to write this part. 4 divided by 2. You know 4 divided by 2 is 2 miles per hour. So who is hiking more quickly? Well, 3 miles per hour is greater than 2 miles per hour, and that would be our buddy Kyle up here. So Kyle gets the gold star for hiking quickly, if that's the goal. I don't know why you'd want to hike particularly quickly. Maybe Julio is stopping to smell the flowers, literally over there. Alright, there's Kyle and Julio right there. They've caught up to each other. How nice. Okay, so they used a number line in this model here, and they're basically just number lining it out. So you've got to keep the miles and the hours each on their own line. So if it's half a mile and a quarter hour, then you want to get to the 1 hour because that's the unit rate you're going for. So you just need to make that 1/4 into a 1 by they doubled it, and then they added another 1/4, and then they got to 1. But over here, since we're starting with 2 hours, we need to go down to 1. So you can do it that way. You can make whole number lines if you want to. I don't want to. I want to just do the math, find the rate of change, do the division. That's what I'm looking at. Division. So we can simplify fractions to find each speed. Guess what? That's what we did above. So it's the same thing here. They wrote it several different ways. They wrote the ratio as 1/4. This is Julio, remember? Julio, 1/2 to 1/4. 1/2 to 1/4 can be written this way, or you can write it that way. It's all the same thing. And then Kyle, 6 to 2, 6 to 2, 6 divided by 2. It's all the same thing. So who does hike more quickly? And how can you use the double number lines to figure out who is hiking more quickly? Well, the double number lines, if you want to make a bunch of number lines, I would put, I'm going to use my typing tool. I'm going to try to remember to use them more because I know you don't want to watch me handwrite all this stuff. I'm going to put you, let's see, it says who hikes more quickly. Okay, we're going to put Kyle. Hikes more quickly. And how can you use the double number lines? Let's say, look for the number of miles that corresponds to 1 hour for each boy. Look for the number of miles that corresponds to 1 hour for each. Let's change it to lad. For each lad. The lad that, sorry, proper grammar, who has hiked more miles hikes more quickly. Seems like a simple answer, right? They must want something more complicated than that, but they don't. You know how I know they don't? Because I have the answer key. So, number 2 here. What is Julio's speed in miles per hour? Explain how you can use the double number line to find Julio's speed in miles per hour. Let's see. Oop, don't drag it. Okay, there we go. He goes, it was half a mile per hour. You can say mile per hour. Half mile per hour. And let's say you, and it's just since it's the double number line, and since it's already made, you find, let's see, you find the ratio for miles per hour, and that's how many, wait a minute, they're asking for the other way. They're asking for hours per mile. Why would you want that? Ridiculous. Okay, so hours per mile, and it is half, but we just have to do it the other way around because usually we're doing miles per hour. So Julio, it was, let's go up here to where we can actually see it, It was over here miles per hour, so they did miles per hour. If they want hours per mile, you have to flip it, right? So that would be 1/4 over 1/2, which is 1/4 divided by 1/2, which is keep, change, flip. 1 times 2 is 2, 4 times 1 is 4, but whenever you have a numerator and denominator that are both even, you can at the very least divide by 2. You can never have a proper fraction where the numerator and denominator are both even numbers. So that's 1/2. There's where we got the 1/2 from. Let's see, can I move that whole thing? Is the whole thing connected? Oh, almost. Nah, I'll leave it there. Okay. So double number line method. I didn't use the double number line method though. I guess you just look at the other way around, huh? I could have just gone up here if they want the double number line. So in this case, you'd go to miles per hour. No, hours per mile. I'm saying it backwards. It's a weird way to put it. Okay, so hours per mile, and this again, 2/4 is 1/2. Okay. So in that case, now that I actually read the question properly, put it, oh, there we go. Okay, so it's half an hour per mile. There we go. You can find the ratio of hours per mile. And then you can divide the number of hours by miles to find the rate. There you go. I mean, the number line's already up there, so just use the number line, or just do the division because it's easier. Okay, so looking at the second model which is the good way, where you just do math. I'm not a fan of the number line, obviously, but that's okay. If it works for you, then use it. If it doesn't, then don't use it. The fraction 1/2 to 1/4 describes Julio's speed in miles per hour. So we've got miles, highlighter, miles per hour. What fraction describes Julio's speed in hours per mile? And what is his speed in hours per mile? So this is the way we did it up above. So the answer to this is this right here. So copy that down there. I did it backwards. The number line threw me off. Let's see if we can fix that for number 4. The fraction 6/2 describes, or 6/2 I should say, describes Kyle's speed in miles per hour. What fraction would describe Kyle's speed in hours per mile? Okay, now we're flipping it over. For hours per mile. What is the speed in hours per mile? Okay. Well, if this is miles per hour, and we want hours per mile, ta-da! But, like I said, these are, oh, that's terrible. There you go. These are both even numbers. You can't have two even numbers, so I'm going to divide my numerator by 2. And I'm going to divide my denominator by 2. So it's 1/3 hour per mile, aka 20 minutes. Do you need a different strategy to find each speed because one involves fractions? Do you need different strategies? Let's see. I'm going to say no. You can just divide, whether they're fractions or not. Thanks to the glory that is complex fractions. I won't write that part. Okay, and then this part is for you. Which strategy do you prefer? Do you prefer the number lines, because you're crazy? Or do you prefer just doing the math? Because, I don't know, maybe you do prefer the number lines. You can if you want to. I forgive you. But go ahead and pause, answer that question real quick, and then unpause when you're done, and... You unpaused? Okay, good. You answered that one, because that one's your opinion. So that one is up to you. Okay, let's use what we have learned, where these are your guided practice problems. What we're going to do together, 7, 8, and 9, and then you've got your own practice pages. And look at this cute little penguin right here. The happy little penguin. Okay, I'm done. A penguin walks south. How nice. It completes the first 1/3 mile in 1/5 of an hour and continues walking at the same rate. What is the penguin speed in miles per hour? Okay, so remember, if it's miles per hour, so arrows need to be on the bottom if you want miles per hour, which is miles divided by the hours to get the unit rate. So that's going to be keep, change, flip, and that is 1 times 5 is 5, 3 times 1 is 3. Now that's an improper fraction, so this answer would work to show me that you understand the general goal of the day. I don't know why I'm doodling. But for, a proper answer on a test, you'd have to simplify that. So just remember, this is a division problem. If you can do it in your head, that's fine, because it is small numbers. But if you're not quite there yet, just remember 5 divided by 3. 3 goes into 5 one time. 1 times 3 is 3. The remainder there is 2. Remainder goes on the top. Divisor goes on the bottom, 1 2/3. So 1 2/3 miles per hour for that beautiful little birdie. Okay, let's see if we can keep doing this. Let's see if we can manage this one. Ooh, multiple choice. I like multiple choice because if you get it wrong, it's not on there, usually. Sometimes they mess with you and they give you obvious wrong answers that are easy to get by mistake. Okay. A maple tree shades an area of 7.5 square meters in a scale drawing. The maple tree shades an area of 12.5 centimeters. Goodness. Okay, so the real one that's meters, so this one's centimeters. Okay, so this is the scale drawing. In the scale drawing, how many square meters represent 1 meter squared? Ooh, look at these big numbers it's given us now. We're diving in. Okay, so we want the rate per 1 meter squared. So if that's our 1 that we want, that needs to be on the bottom. Now we've got mixed numbers in our fractions. So this is the one we're figuring out, and we want this one to become 1. So now 12.5 divided by 7.5. So this is layering on another skill that hopefully you recall, and that's converting these mixed numbers to improper fractions. I always teach my students, I'll bring it up here in another color, to use the loop method, where you go 2 times 12 plus 1, and that's your new numerator. So 2 times 12 is 24, plus 1 is 25. That's a times, that's a plus. And the denominator stays the same. Same thing over here for the 7.5. It's times, it's plus. What's multiplication? It's addition. So 2 times 7 is 14, plus 1 is 15. Denominator stays the same. Okay, so now back down here to where we were, we've got 25 over 2 divided by 15 over 2. It's going to get a little more complicated, but it's kind of a shortcut. So if you don't remember how to do this part, I'm going to help you find an actual shortcut. So 25, let's keep, change, and flip. Now these are numbers I'm not going to want to reduce when I'm done. So you can just go across. 25 times 2 is 50. I should make a mark here because I know you can't see my mouse. 25 times 2 is 50. 2 times 15 is 30. And you can reduce, actually that's easy to reduce too. That would be 50 over 30, which you can reduce by crossing out the zeros. But I'm going to show you one more way to do it. We're going to cross reduce. And this only works with multiplying fractions. So if you're worried about having big numbers at the end, you can reduce in multiplication diagonally. So look at the 2 and the 2. We can reduce that by 2 to 1 and 1. Look at the 25 and the 15. Those can both be reduced by 5. So 25 divided by 5 is 5. 15 divided by 5 is 3. So now this has become 5 over 1 times 1 over 3, which is 5 over 3. So both of those ways of doing it work. Whichever way works best for you is fine. This is still an improper fraction. Run out of room a little bit, but just to throw in that improper fraction, remember 3 goes into 5 one time. There's 2 left over. Denominator stays the same. So there's your actual answer. Oh look, they left it as an improper fraction over here. You didn't have to do that part. Sad proper fraction. Sad mixed number over there. But there you go. 5/3. Look at all that math. I like all those numbers. Okay, last practice one to do together. And then I'm out of math to do for the day. Don't you feel sorry for me? I do. Okay, Dahlia is mixing paste. For every 1 2/3 cups of water, she uses, cups of water. she uses 2.5 cups of flour. How much flour does Delia need for each cup? So this is the unit we want. This is the thing we want. One of each 1 cup. 1 cup of water. That's the unit we're going for. So that's the one that goes on the bottom. So 2, oops, that's the flour. I already messed it up. 1 2/3 cups of water. That's the thing we want 1 of, so that goes on the bottom. 2.5 cups of flour on the top. Change that as a division problem. That's going to be 2.5 divided by 1 2/3. We're going to make that little loop again. 2 times 2 plus 1. That's going to become 5/2. And then keep our division for now. 3 times 1 is 3 plus 2 is 5/3. And then we're going to keep, because it's still division of fractions. Change, flip. Now this is another instance. Remember, you're multiplying. That's the only time you can cross reduce. So I can cross reduce here 5 and 5. I can divide both of those by 5, and now they're 1 and 1. So 1 times 3 is 3. 2 times 1 is 2. That's improper. It's got, although it accepted improper at the last problem, didn't it? But I don't like improper fractions. So 2 goes into 3 one time. There's 1 left over out of 2. So it's 1.5 cups of flour. Okay. Now it's basically just fraction division is all you're doing on these pages. So page 41, page 42, those are your practice pages. I would like you to submit those to Canvas as soon as you're able to, and if you need any help with that, ask a parent, ask YouTube, or message me. Good luck.